Namaste, good morning to you all, and also welcome to another session of online mathematics class. In the previous session, we have discussed some elementary row operations and column operations, and also we have learned how to calculate the inverse of a 2 by 2 matrix. Hope you have revised well. And in today's session, we shall discuss how to find the inverse of a 3 by 3 matrix. In today's session, we shall discuss elementary transformation of a 3 by 3 matrix. That means the magic pattern for a row operation in case of a 3 by 3 matrix. In the previous lesson, we have discussed how to find out the inverse of a 2 by 2 matrix. In that case, we used to start by writing a result that A is equal to IA, and left side that particular A we have to change it into identity matrix of order 2 by 2. The same thing only here also. The general form of a 3 by 3 matrix is written here, that is A11, A12, A13, A21 etc. to A23, A31 etc. to A33. This is the left side matrix that we have to change it in an identity matrix of order 3 by 3, that is 1 0 0 0 1 0 and 0 0 1. So we have to follow a particular pattern that is easy for us to make that particular matrix to an identity matrix. The pattern is, first we have to change the first element, that is A11 as 1, and next you have to move down to A21th element, that you have to make it 0. Next you have to move down to A31, and that particular element you have to make it 0. So first we have started from A11, first element we change to 1. Next to move down A21, make it 0. Next to move down to A31 and make it 0. Next you have to move to A22. So that particular element you have to make it 1. Then you have to move down and come to A32 and make it that particular element 0. Then you have to move right and go to A33, and that particular element you have to make it 1. Then you have to move up and get A23 and make that particular element to 0. Next you have to move up and you will reach to A13 and make that particular element to 0. Then you have to move left, you will reach to A12 and make that particular element as 0. So now the identity matrix is ready here, 1 0 0 0 1 0 0 0 1. Once again I will tell you, first you have to start with A11, then go to A21, then go to A31, then go to A22, then come down to A32, then move to A13, then move to A23, then move to A13 and come back to A12. The pattern goes like this. First you have to go down, next you have to go to A22th position. This is the position, A22th position, and again you have to move down, move right, move up and turn left. So this is the pattern for row operation. And in case of column operation, the magic pattern is like this. As before, we have to write the general form, that is A11 to A13, A21 to A23, A31 to A33. We have to change this one to the identity matrix of order 3, 1 0 0 0 1 0 0 0 0. So the column operation is like this. As before, the first one A11 element we will start, then you have to move right and you will come to A12, then move on to A13 and change that particular element to 0. Then as before, come back to A22, move on to A22 and make that particular element as 1. Next you have to come to A23 and make that particular element to 0. Then you have to come down to A33, make that particular element to 1, and you have to move down to A32 and that particular element you have to change to 0. Then go to A31 and make that particular element 0. Then go to A21 and make that element as 0. So this is the pattern, and when you draw the pattern, move right, then again as before come to A22 position, then go back to A23, go down, go left and go up. So this is the pattern for column operation. So why we are following this particular pattern in the sense, when you are appearing this type of questions in an examination, so it will be confusing if you are not particularly following a particular pattern. So that's why stick on to a particular pattern and then apply that pattern in that all the questions in the same way, so that it will be easy for you to calculate the inverse of any given matrix of order 3 by 3. Now we shall try to solve some questions from the exercise. Using elementary transformations, find the inverse of each of the following matrices. Question number 15. There is a 3 by 3 matrix is given to you. We have to find the inverse of this matrix. So before start calculating this inverse, so I would like to give you a reminder that please keep a piece of paper or a rough note with you for doing the rough calculations, because here rough calculations are not included in the slide and also only the operation part is given. If you feel inconvenience or difficulty, you have to write the operation in a piece of paper and you have to substitute it and calculate that value. For that purpose, you please keep a piece of paper or a rough note with you. As before, we have to assume the question matrix as A is equal to the given matrix we have taken, and then we have to write the result like the previous question, that is A is equal to IA. We have to substitute the values. A matrix is substituted is equal to I into A. Then just to keep a route map in your mind, that is, this is the way I'm going for a row operation. So I have to move down and then I have to go to A2 to the position. Again I have to come down, I have to move right, go up, turn left. So this is the route map. Maximum we will follow this one. Okay, so first and foremost thing, we have to change this element 2, we have to change to 1. For that purpose I'm going for the calculation, that is R1 changes to R1 minus R3. This is the operation. After doing the operation, R1 is 2, 2 minus 3, 2 minus 3 is minus 1. Then minus 3 minus minus 2, minus 3 minus minus 2 is minus 1. Then 3 minus 2, 3 minus 2 is 1. Then R2 remains the same and R3 also remains the same. Equal to, on the right side identity matrix, same operation you have to do. 1 minus 0, R1 minus R3. 1 minus 0 is 1, 0 minus 0 is 0, 0 minus 1 is minus 1. R2 same, R3 same, as it is we have written into A. Now I need a 1 here, not a minus 1, so I have to change this minus sign. Simple, just to do the operation, minus 1 into R1, just to multiply minus sign in this R1, this minus becomes plus. After doing the operation, the row 1 becomes minus 1 into minus 1, that is 1, minus 1 into minus 1, again 1, 1 into minus 1, that is minus 1. R2 same, R3 same, as it is we have written. Equal to, on the right side matrix, again if you multiply minus 1 with R1, 1 into minus 1, that is minus 1. Then 0 into minus 1, that is equal to 0. Then minus 1 into 1, that is equal to 1. Minus 1 into minus 1, sorry. Minus 1 into minus 1, that is equal to 1. So R1 is changed to minus 1, 0, 1. R2 remains the same. R3 also remains the same into matrix A. Now I am going for multiple operations, means 2 operations at a time. If you feel convenient, you do it, or else you can go for separate calculation. It's not a problem. Next, first part I have done, that is first element I made it 1. Next I have to change this 2 to 0 and this 3 also I have to change to 0. So for that I am using the operations like this. R2 changes to R2 minus 2R1 because it is easy now. First element in R1 is 1. So if I multiply 2 with this one and if I subtract it from here, 2 minus 2 becomes 0. That's what it is written, R2 minus 2R1. And another operation is next element, third row, first element is 3. Third row, first element is 3. So if I subtract 3 from 3, 3 minus 3 means 0. How I will get 3? I just multiply 3 with 1. So 3 minus 3. R3 minus 3R1. That is the operation. After doing the operation, R1 remains the same. 1, 1 minus 1. It just copy the same numbers. And next is R2 minus 2R1. That is 2 minus 2 2 into 1. 2 minus 2 into 1 is 0. Next is 2 minus 2 into 1. That is equal to again 0. 3 minus 2 into minus 1. That is plus 2. That is 3 plus 2. That is equal to 5. Then third row also I am changing. Third row is 3 minus 3 into 1. 3 minus 3 into 1 is 3 minus 3. That is equal to 0. Next is minus 2 into minus 3 into 1. Minus 2 into minus 3 into, minus 2 minus 3 into 1. That is minus 2 minus 3. That is equal to minus 5. Next is 2 into minus 3 into minus 1. So 2 plus 3, that becomes 5. So carefully you have to do. If you feel inconvenience, write and do it. Equal to, on the right side, just R1 remains the same, minus 1, 0, 1. And R2 we are changing. R2, how we are changing? R2 minus 2 R1. That is 0 minus 2 into minus 1. 2 into minus 1 is minus minus plus, that is 0 plus 2, that is equal to 2. 0 plus 2 is 2. Next is R2 is 1. R2 minus 2 into 0, that is 2 into 0 is 0, that is 1 minus 0, that is equal to 1. Next R2, 0 minus 2 into 1, 2 into 1 is minus 2, so 0 minus 2 is minus 2. Next R3 we are changing. R3 minus 3 R1. R3, first element is 0. 0 minus 3 into minus 1. 3 into minus 1 is minus minus becomes plus. 3 into 1, 3. 0 plus 3 is 3. Next is 0 minus 3 into 0. 0 minus 3 into 0 is 0. Next 1 minus 3 into 1. 1 minus 3 into 1 is 1 minus 3, that is equal to minus 2. So it was a Herculean task for you if you are not concentrating properly. If you concentrate, you can just do it like a game. Now first part, this row I just completed. See this root map, this portion is over. Now I have to move here. Okay, so that element I have to change. That is R2 and R3 I am interchanging, because here the element is 0. I have nothing to do. So I have to make a particular number here, then only it will be easy for the calculation. So R2 and R3 I am interchanging. After interchanging R2 and R3, symbol R1 remains the same, 1, 1 minus 1. This R3 will come into R2th position, that is 0 minus 5, 5 will come here, and 0, 0, 5 will come as R3. Equal to, here also same operation, R2, R3 changing. Minus 1, 0, 1 same. And 3, 0, minus 2. R3 will come here as R2. 3, 0, minus 2. And here this R2, 2, 1, minus 2 will come here as R3 into A. Now it is easy here to change this one to 1. So very simple. Just divide with minus 5. Divide with minus 5 or multiply with minus 1 by 5, both are same. So R2 changes to minus 1 by 5 into R2. After doing that calculation, R1 remains the same, 1, 1 minus 1, it remains the same. And R2 is changing, minus 1 by 5 into 0, minus 1 by 5 into 0 is 0. Minus 1 by 5 into 5, that is minus minus becomes plus, 5, 5 cancelled, it becomes 1. Then next is minus 1 by 5 into 5, that is minus 1. And R3 remains the same, 0, 0, 5 equal to, and on the right side also R1 remains the same, minus 1, 0, 1. And R2 is changing to minus 1 by 5 into R2, that is minus 1 by 5 into 3, that is minus 3 by 5. Minus 1 by 5 into 0, that is 0. Minus 1 by 5 into minus 2, that is 2 by 5. And R3 remains the same, that is 2, 1, minus 2. So almost I have reached here, and this automatically, this also I have got a 0. So some part is reduced there. Next I am changing R1 to R1 minus R2. R1 to R1 minus R2 in the sense, so here this element I can make it 0. This element I have to make it 0. For that what I have done is R1 changes to R1 minus R2. See here, R1, 1 minus 0, 1 minus 0 is 0, and 1 minus 1, that is equal to 0. Then minus 1 minus 1, that is minus 1 plus 1, that is equal to 0, and the remaining things are same, 0 1 minus 1 0 0 5 equal to, here also R1 is minus 1 minus 3 by 5, minus 1 plus 3 by 5, then you do the calculation, it becomes minus 2 by 5. Next, 0 minus 0, that is equal to 0. Next, 1 minus 2 by 5, 1 minus 2 by 5 is 3 by 5 will be getting, and the balance remains the same, R2, that is minus 3 by 5, 0, 2 by 5, and 2 1 minus 2. Next operation I am going, R3 changes to 1 by 5 R3, means I have to go this one with 1. So here little bit of deviation we have made from this root map, because as you know that here 1 here 1, so it is easy to make this to 0. If we are making this to 0, other calculation will be easy for us. That's why we have little deviated from this root map. Okay, so it is not a problem, because we need the calculation little bit easier. For that purpose only this 1 and minus 1 we have seen, that's why suddenly we made these two elements 0. So next we have to come here, that is 5, we can make it easily 1, that R3 changes to 1 by 5 R3, just multiply with 1 by 5, implies R1 remains the same 1 0 0, R2 remains the same 0 1 minus 1, then R3 1 by 5 into 0 0, 1 by 5 into 0 again 0, then 1 by 5 into 5, that is equal to 1, equal to, on the right side matrix R1 remains the same and R2 remains the same, R3 is changing, that is 1 by 5 into 2, that is equal to 2 by 5, 1 by 5 into 1, that is equal to 1 by 5, then minus 2 into 1 by 5, that is equal to minus 2 by 5. Now in the left side matrix, if you check 1 0 0, then 0 1, this one we have to make it 0, then it will be fine. So for that purpose, the another operation we are going to do, that is R2 gives R2 plus R3, R2 and R3, if you plus it, this becomes 0. The operations, after doing the operations, R1 remains the same 1 0 0, we have copied down, then just R2 changes to R2 plus R3, R2 plus R3 means 0 plus 0, 0 plus 0 is 0. The next is 1 plus 0, 1 plus 0 is 1. Next is minus 1 plus 1, minus 1 plus 1 is 0. Then R3 remains the same 0 0 1. Next you have to move down to the right side matrix, R1 remains the same, just same numbers we have written. Next R2 changes to R2 plus R3, that is minus 3 by 5 plus 2 by 5, that is minus 3 plus 2, that is minus 1 by 5. Next 0 plus 1 by 5, 0 plus 1 by 5 is 1 by 5. Next 2 by 5 minus 2 by 5, that is equal to 0, and R3 remains the same. Now it is happy to see on the left side almost all the elements we have got. Now finally we can go for the calculation answer, that is A inverse is equal to minus 2 by 5 0 3 by 5, the same matrix, minus 2 by 5 0 3 by 5, minus 1 by 5 1 by 5 0, 2 by 5 1 by 5, minus 2 by 5. So this is our inverse. As we it is quite clear that if you do the calculation interestingly and without considering it as a burden, it will be easy to get the answer, otherwise it will be confusing and complicated. So first you just give your concentration and take interest and do it, then it will be easy for you to come to the conclusion. And another thing is that just we can go, sometimes we can go out of this mental map, because we need easy calculation. In some cases there are some rows and columns easily will get it as 1 or 0, so in that case we can just go out of this box and we can do our own calculation. Hope it is clear. Now we shall move on to question number 16. There is a 3 by 3 matrix is given to you. We have to find the inverse of this matrix. As before, we have to take the matrix as A. A is equal to 1, 3, minus 2, minus 3, 0, minus 5, 2, 5, 0. And we have to write the result. A is equal to IA. Substitute the values. A is substituted here, 1, 3, minus 2, minus 3, 0, minus 5, 2, 5, 0. Identity matrix is substituted into A. Now we have to give just to recall on that particular root map we have learned before. But again, I want to tell you that this is not a compulsory one. This is just you can use it as a guideline, but in some cases or some when you reach some row or column, we feel that some other calculation is convenient, then you can go for that. But this you can use it only as a guideline. Sometimes we have to go out of this box. So first element here, when you check, it is 1. So it is quite happy to see 1 as a first element, because we no need to go for again converting that. Now we shall move on to this minus 3 and this 2. We have to make this minus 3 as 0 and this 2 as 0. For that we are using the transformation. R2 gives R2 plus 3R1. Next R3 gives R3 minus 2R1. After doing the transformation, R1 is not mentioned here, so R1 remains the same, 1, 3 minus 2, as before 1, 3 minus 2 it is same. Now R2 is changing, R2 plus 3R1, R2 that is minus 3 plus 3 into 1, minus 3 plus 3 into 1 is minus 3 plus 3, that becomes 0. Next R2, 0 plus 3 into 3, 0 plus 3 into 3 is 9. Next R2 element is minus 5 plus 3 into minus 2, that is minus 5 minus 6, that becomes minus 11. And again R3 changes to R3 minus 2R1. R3 is 2 minus 2 into R1, that is 2 into 1, that is 2 minus 2, that becomes 0. Next is R3 is 5 minus 2 into 3, 5 minus 2 into 3 is 5 minus 6, that becomes minus 1. Next is R3 element is 0 minus 2 into minus 2, that means 0 plus 4, that becomes 4. Again here on the right side, R1 remains the same, 1, 0, 0, and R2 is changing, R2 plus 3 R1, R2 that is 0 plus 3 into 1, that is equal to 3. Next R2 is changing as R2, that is 1 plus 3 into 0, 1 plus 3 into 0 is 1. Next is 0 plus 3 into 0, that is 0 plus 0 is 0. Next R3 changes to R3 minus 2 R1 transformation. R3 element is 0 minus 2 into 1, 0 minus 2 into 1 is minus 2. Next here element 0 minus 2 into 0 becomes 0. Next 1 minus 2 into 0, 1 minus 2 into 0 is 1. So now when you check, I have to first column completed. When you check this transformation map, this part is over, first column part. Then I have to move on to this position, A22th position, that is 9. But when you check here, just below that there is a minus 1. So if I bring this one to here instead of 9, the calculation will be little more easier. So what I'm going to do is I'm going to interchange R2 and R3. So when I interchange R2 and R3, after doing the transformation, R1 remains the same, 1, 3 minus 2 remains the same, and R2 0, 9 minus 4 is coming here as R3, 0 minus 0, 9 minus 11. Next here R3 is 0 minus 1, 4 as R3. That R3 will come here as R2, 0 minus 1, 4, because we are interchanging R2 and R3. The same transformation here also, 1, 0, 0 first row same, and 3, 1, 0 will come here as third row, and here minus 2, 0, 1 will come here as second row, minus 2, 0, 1, because second row and third row are interchanged. Now here it is minus 1. We don't want minus 1, we need 1 only. So just we have to go for the transformation. For cancelling that minus 1, just multiply minus 1 with row 2. So row 1 remains the same, that is 1 3 minus 2, same like here 1 3 minus 2, and row 2 0 into minus 1, that becomes 0 only. Next minus 1 into minus 1, that becomes 1. Next minus 1 into 4, that becomes minus 4. And R3 0 9 minus 11, 0 9 minus 11, it remains same. And on the right side also R1 1 0 0 remains the same. R2 is changing with minus, just multiplying a minus 1. So minus 1 into minus 2, that becomes plus 2. Then minus 1 into 0, that becomes 0. Next minus 1 into 1, that becomes minus 1. And R3 same, 3 1 0 remains the same. Now coming out of this box, okay, we are not following this box now, just I am going to make this 3 as 0 and this 9 as 0, then the calculation will be little more easier. For that purpose, the transformation is R1 changes to R1 minus 3 R2, means if I subtract 3 from here, 3 minus 3 0. For that this calculation I am using. And another one is R3 changes to R3 minus 9 R2. See here 9 is there, if I subtract a 9 from here, it becomes 0. This calculation I am using. After doing the transformation, R1 changes to R1 minus 3 R2. See R1 is 1 minus 3 into 0. 1 minus 3 into 0 is 1 only. Next R1 3 minus 3 into 1. 3 minus 3 into 1 is 0. Next R1 minus 2 minus 3 into minus 4. That means 12 minus 2. 12 minus 2 is 10. Then R2 is not mentioned here, R2 remains same, 0 1 minus 4, here same 0 1 minus 4, just to copy down. Next R3 is changing, R3 minus 9 R2. See R3 is 0 minus 9 into 0. 0 minus 0, that becomes 0. Next R3 9 minus 9 into 1. 9 minus 9 again 0. Next minus 11 minus 9 into minus 4, that is 36 minus 11, that becomes 25. And here also on the right side R1 is changing, R1 minus 3 R2. R1 minus 3 R2, that is R1 1 minus 3 into 2, that is 1 minus 6, that becomes minus 5. Next R1 0 minus 3 into 0, 0 minus 0 becomes 0. Next R1 0 minus 3 into minus 1, 3 into minus 1 means minus 3 into minus 1 means plus 3. R2 there is not mentioned here, so R2 remains the same, 2 0 minus 1 remains the same. And R3 changes to R3 minus 9 R2. R3 is 3 minus 9 into 2, that is 3 minus 18. 3 minus 18 is minus 15. Next R3 is 1 minus 9 into 0. 1 minus 9 into 0 is 1. Next 0 minus 9 into minus 1, that is 0 plus 9, that becomes 9. Now both the columns 1 0 0, here 0 1 0, only we need to go for this third column only to change. For that, first I am going for this 25. We have to make it this 25 as 1, just to divide it 25 or multiply with 1 by 25. After doing the transformation, R1 remains the same, 1 0 10, and R2 remains the same, 0 1 minus 4, 0 1 minus 4 here, and R3, that is 0 multiply with 1 by 25. 1 by 25 into 0, that becomes 0. 1 by 25 into 0 again 0. Next 1 by 25 into 25, it becomes 1. Here also R1 remains the same, minus 503, here also minus 503. Next 20 minus 1, here also 20 minus 1. Next R3 is changing. R3 is changing means 1 by 25 into minus 15, that is minus 15 by 25. When you cancel 5, it becomes minus 3 by 5. Next 1 by 25 into 1, that is 1 by 25. Next 1 by 25 into 9, that becomes 9 by 25. Now we have to change this 10 and this minus 4 only. For that purpose, we are going for the transformation. R2 changes R2 plus 4 R3, because if I subtract 4, here minus 4 is there. If I add 4, it becomes 0. If I subtract 10 from here, it becomes 0. That calculation we are doing. R1 changes R1 minus 10 R3. After doing the transformation, it becomes R1 is taking R1 changes R1 minus 10 R3. See, 1 minus 10 into 0. 1 minus 10 into 0 is 1 only. Next, R1 is 0 minus 10 into 0. 0 minus 10 into 0 is 0. Next, R1, that is 10 minus 10 into 1, that is 10 minus 10, that becomes 0. Next, R2 is changing R2 plus 4 R3, that is R2. R2 is 0 plus 4 into 0. 0 plus 4 into 0 is 0 only. Next, R2 is 1 plus 4 into 0. 1 plus 4 into 0 is 1 only. Next is R2. R2 is minus 4 plus 4 into R3. 4 into R3 is 4 into 1, that is minus 4 plus 4, that becomes 0. Next, third row, that is same, 0 0 1 remains the same. And when you come to the right side matrix, R1 changes to R1 minus 10 R3, that is R1 here. When you check, minus 5 minus 10 into R3, that is 10 into minus 3 by 5. When you go for the calculation, you will get it as 1. Please write and do the calculation. Okay, once again, R1 changes to R1 minus 10 into R3. See, R1th element is minus 5 minus 10 into minus 3 by 5. When you calculate, you will get it as 1. Next is R1 element is 0, that is 0 minus 10 into 1 by 25. When you calculate, you will get it minus 2 by 5. Next, again R1 third element, that is R1 minus 10 R3. If you do R1 is 3 minus 10 into 9 by 25. When you do the calculation, you will get minus 3 by 5. Now move on to R2 we have to take R2 plus 4 R3, that is R2 first element is 2 plus 4 into minus 3 by 5. When you calculate, you will get minus 2 by 5. Next, R2 element is 0 plus 4 into 1 by 25, that is 4 by 25. You will get the calculation. Next, minus 1, R2 element is minus 1 plus 4 into 9 by 25. You will get it as 11 by 25. And here the third row, that is minus 3 by 5, 1 by 25, 9 by 25. It remains the same because we have not used any transformation. Now when you check the left side, it becomes an identity matrix. And here in the last stage, the calculation denominators are there. So better you go for, if you are not able to do mental calculation, you just go for writing and doing paper and pen work. That will be easy for you. Then we have to go for the final answer. Now we shall discuss question number 17. There is a 3 by 3 matrix is given to you. You have to find out the inverse of this matrix. Assume that given matrix as A. Write the statement, that is A is equal to IA. Substitute it. A substituted is equal to I is the identity matrix of order 3 into A. Then we have to just have a quick recall on that particular mind map. As I said before, this is not a compulsory one. It is just a guideline only. Whenever we want to make changes, we can make changes. Our aim is to get the answer easily and accurately. That's all. Now go for the first operation, that is R2 changes to R2 minus 2R1. So not like this one. We are making a little bit of change here that I will tell you later why we made such a change here. So actually we have to change the first element here, but we did not change it. We went to R2. I tell you why we are changing that way. That we'll discuss later. So R2 changes to R2 minus 2R1. In the sense, R1 remains the same. 20 minus 1 remains the same. And R2 first element is 5 minus 2 into 2. 5 minus 2 into 2 is 5 minus 4. 5 minus 4 is 1. Next is R2 is 1. 1 minus 2 into 0. 1 minus 2 into 0 is 1 only. Next 0 minus 2 into minus 1. That is equal to plus 2. That is 0 plus 2. That is plus 2. R3 remains the same, 0, 1, 3. And right side also R1 remains the same, 1, 0, 0. And R2 will change like this, R2 minus 2 R1. That is R2, 0 minus 2 into 1. 0 minus 2 into 1 is minus 2. Next 1 minus 2 into 0. 1 minus 2 into 0 is 1. Next 0 minus 2 into 0. That is equal to 0. And R3 remains the same, 0, 0, 1 here like this. Now I will tell you why we have changed this R2 first, because when you look at this one, first element is 2, below that there is a 5, and down R3 first element is 0. Unless or otherwise an element 1 is there in any one of these 2, 5 or 0, it is not easy for us to calculate. That's why first we made an element 1 by changing R2 this way. So that's why we have used this transformation. Next we have to move R1 interchange to R2. Means if I make it this 1 here, the first condition is satisfied. Means A11 element will be 1. So R1 interchange with R2. While doing that calculation, this 1, 1, 2, that is R2th row will come here as R1th row. That is 1, 1, 2. Then 2, 0 minus 1. This is here R1 will come here as R2, 2, 0 minus 1. And R3, 0, 1, 3 remains the same. Equal to, here also R1 and R2 will change. That is minus 2, 1, 0 will come here as R1. 1, 0, 0 here will come here as R2. R3 remains the same, 0, 0, 1. Now move on to the next transformation, that is R2 changes to R2 minus 2R1. After doing the transformation, R1 remains the same, 1, 1, 2. I have written 1, 1, 2. And R2 changes to R2 minus 2R1. R2, that is 2 minus 2 into 1. 2 minus 2 into 1 is 0. Next is 0 minus 2 into 1, that is minus 2. Next is minus 1 minus 2 into 2, that is minus 1 minus 4, that becomes minus 5. Then R3 remains the same, 0, 1, 3, 0, 1, 3. And on the right side, R1 same, minus 2, 1, 0. Here also minus 2, 1, 0. Next when you check, R2 changes to R2 minus 2R1. That is R2 in the sense, first element is 1 minus 2 into minus 2. That is 1 plus 4. That becomes 5. Next 0 minus 2 into 1. 0 minus 2 into 1 is minus 2. Next 0 minus 2 into 0. That is 0 minus 0 is 0. Final row 3, 0, 0, 1 remains the same. Now you see the first column, it becomes 1, 0, 0. We just followed this way. But of course it is not in the order. According to our convenience, we made little bit of difference. Next we have to change R2 and R3. We have to interchange, because here 1 is there. So instead of doing calculation this part, we can easily make this one, you can easily bring this one to R2 side. So that's what we have done here. Little bit of common sense, that's all. After doing that calculation, R2 and R3 will be interchanged. R1 remains the same, 1, 1, 2, 1, 1, 2. 0 minus 2 minus 5 here is R2 will come here as R3, 0 minus 2 minus 5. And this R3, 0, 1, 3 will come here as R2, 0, 1, 3. And here also same transformation, minus 2, 1, 0 remains the same. And 5 minus 2, 0 will come here as R3 and 0, 0, 1 will come here as R2 into A. Now, move on to next transformation, that is R1 changes to R1 minus R2. That means I want to make this one 0 and again this one I want to make 0. Okay, in the previous two questions also we have done that way only. After making this A22 element 1, just after that we have changed the above and below elements 0. In the previous two questions also we have done that way only. We didn't follow this mental map. So R1 changes to R1 minus R2 and R3 changes to R3 plus 2R2. After doing the transformation, R1 changes to R1 minus R2. See, 1 minus 0, 1 minus 0 is 1. 1 minus 1, that is equal to 0. 2 minus 3, 2 minus 3 is minus 1. R2 remains the same, 0, 1, 3 remains the same. And R3 changes to R3 plus 2R2. R3 is 0 plus 2 into 0. 0 plus 2 into 0 is 0 only. Next, minus 2 plus 2 into 1. Minus 2 plus 2, that becomes 0. Next, minus 5 plus 2 into 3. Minus 5 plus 2 into 3 is 6. That is minus 5 plus 6 is 1. And on the right side matrix, R1 again will change R1 minus R2. R1 minus R2 in the sense minus 2 minus 0. Minus 2 minus 0 is minus 2 only. 1 minus 0. 1 minus 0 is 1 only. 0 minus 1, that becomes minus 1. R2 remains the same, 0, 0, 1. It becomes 0, 0, 1 only, here no change. And R3 will change to R3 plus 2R2. R3 is 5 plus 2 into 0. 5 plus 2 into 0 is 5 only. Next, minus 2 plus 2 into 0. Minus 2 plus 2 into 0 is minus 2. Next, 0 plus 2 into 1. 0 plus 2 into 1 is 2. Next, we have to move on to another transformation, that is R1 changes to R1 plus R3. R1 changes to R1 plus R3 means we want to make this one 0 now. So it is easy to make 0 because minus 1 is here, plus 1 is here. If we add these two, means R1 and R3, if you add, this becomes 0. And R2 changes to R2 minus 3R3. This one we want to make it 0. For that, just subtract R3 after multiplying with 3, subtract from R2. After doing this calculation, after doing this transformation, the matrix will go like this. R1 changes to R1 plus R3. That is 1 plus 0. That is 1. Next, 0 plus 0. That becomes 0. Minus 1 plus 1. That becomes 0. So R1 is changed. Now R2 changes to R2 minus 3R3. So R2 is 0 minus 3 into 0. 0 minus 3 into 0 is 0. Next, 1 minus 3 into 0. 1 minus 3 into 0 is 1. Next, 3 minus 3 into 1. 3 minus 3 into 1 is 0. Next, 0, 0, 1, R3 remains the same. And on the right side matrix, again R1 changes to R1 plus R3. R1 is minus 2 plus 5. Minus 2 plus 5 is 3. Next, 1 minus 2. 1 minus 2 is minus 1. Next, minus 1 plus 2. Minus 1 plus 2 is 1. And R2 changes to R2 minus 3R3. That is R2. R2 is 0 minus 3 into 5. That is minus 15. It is written here. Next, R2 0 minus 3 into minus 2. That is 0 plus 6. That becomes 6 here. Next, R2, that is 1 minus 3 into 2. 1 minus 3 into 2 is 1 minus 6. That becomes minus 5. Now, finally, the third row, that is 5 minus 2, 2. It becomes same. Now, On the left side, if you check, it becomes an identity matrix of order 3. So finally, A inverse is equal to 3 minus 1, 1, minus 15, 6, minus 5, 5, minus 2, 2. That is this matrix. Hope it is clear. Now we shall discuss the last question of this exercise. Matrices A and B will be inverse of each other only if AB equal to BA, AB equal to BA equal to 0 matrix, AB equal to 0 matrix, BA equal to identity matrix, or AB equal to BA equal to identity matrix. It is quite simple question, and according to the definition of the inverse of matrices, it is quite clear that AB equal to BA equal to I. When you multiply A and B and B and A, if you get the identity matrix only, we will tell that A is the inverse of B or B is the inverse of A. So here option D is the correct answer. So hope it is clear. Dear students, now we have learned how to find the inverse of 2 by 2 matrix as well as 3 by 3 matrix. In the examination point of view, it is quite important that you have to learn how to find the inverse of 2 by 2 as well as 3 by 3 order matrices in elementary transformation method. Unless or otherwise you practice regularly, you will not be able to get the answer in the examination. So please keep practicing, and thank you for watching.